Newton's first law explains how a non-moving object will not move and a moving object will continue to move in the same direction and speed until changed by any outside means. The skateboarder rode at a constant speed until the outside force, the rock, made him stop moving or to be at rest, literally. This car is an example of a free body diagram. Free body diagrams show the effect of all forces acting on an object. The net force, or the sum of all the forces, determines which direction the object goes and its acceleration rate. If an object lacks a net force, it can either be at rest or moving at a uniform speed.
Newton's second law explains the relationship between net force, mass, and acceleration by using the equation force equals mass times acceleration. The F-net and acceleration must be in the same direction since they are both vectors. This is a picture of a biker. The biker has a mass of 30 kilograms and an acceleration of 5 meters per second squared. To find the unknown value, the net force, we use the equation F-net equals mass times acceleration. We plug in 30 for mass and 5 for acceleration. We then multiply these two values to get the F-net, which is 150 newtons. The more mass the object has, the more force it requires to cause it to accelerate. It would take a smaller force to move the empty box on the right than the full box on the left. The larger the force applied to an object, the quicker the object will accelerate. The harder the man hits the pressure plate, the faster the metal cylinder will hit the bell.
Newton's third law explains that for every action there is an equal and opposite reaction. Since a man is pushing on the wall is also pushing back on him with the same and opposite force. Objects of different masses are affected differently by the action and reactions. Since the elephant has much more mass than Newton, they are both affected by the action and reaction forces, but since Newton has less mass, he accelerates more from the action itself than the elephant.